Hello and welcome to this screencast on finding missing information in right triangles. Previously, we looked at the sine and cosine functions from a new perspective. Specifically, we observed that in a right triangle where one of the non-right angles is theta, that the cosine of theta is the adjacent side divided by the hypotenuse, and that the sine of theta is the opposite side divided by the hypotenuse. Let's use these new perspectives to determine missing information in some right triangles. So our first example, we're going to determine the exact values of as many of the remaining side lengths and angle measures that we can. We have a right triangle with a hypotenuse of 8 and a non-right angle of measure pi over 8 radians. So we'll draw our right triangle. Let's call this angle pi over 8, and we know the hypotenuse is 8, so we have our adjacent side to our angle and our opposite side. From our new perspective, we know that the cosine of pi over 8 is going to equal the adjacent side divided by the hypotenuse, which is 8. To get the adjacent side alone, we're going to multiply both sides by 8. And that is going to be our exact answer for the adjacent side. 8 times the cosine of pi over 8. Similarly, we know that the sine of pi over 8 is going to equal the opposite side divided by 8. Again, we can multiply both sides by 8, and we'll see that the opposite side equals 8 times the sine of pi over 8. So let me just label that here. 8 times the sine of pi over 8. So at this point, we have found all 3 sides of the triangle, and the last thing that we're going to work on is finding this missing angle. So you may remember that all 3 angles would add up to 180 degrees. We know we have a right angle, which is 90 degrees. So that actually tells us that these other 2 angles would have to add up to 90 degrees. However, we are in radians, not degrees. So you'll need to remember that 90 degrees is equivalent to pi over 2 radians. So what we know is that pi over 8 plus this other angle, let's just call that angle alpha. So pi over 8 plus alpha would have to equal pi over 2. So that missing angle would equal pi over 2 minus pi over 8. If we get a common denominator, we'll have 8 pi over 16 minus 2 pi over 16. So that missing angle is 6 pi over 16 radians, or if you want to reduce that, 3 pi over 8 radians. So now we know all 3 angles in that triangle and all 3 sides. We have completely solved that triangle. Let's look at another example. Determine the exact values of as many of the remaining side lengths and angle measures that you can. We have a right triangle with a hypotenuse of 8 and one leg of length 3. So notice this time we do have a right triangle, but we don't know any of the other angles. We just know the hypotenuse is 8 and one of these legs is 3. Again, my triangle is most likely not at all to scale. So we could use the Pythagorean theorem to find this missing leg. We know that a squared plus 3 squared would equal 8 squared. So a squared equals 9. Whoop, let me back up there. A squared plus 9 equals 64. So a squared equals 64 minus 9, which would be 55. And so a would equal the square root of 55. So we have found the missing side. We now know all 3 sides of that triangle. And because we have not talked about inverse trigonometry yet, we do not have a way to find those missing angles. So this is as much of the information as we can find for this triangle at this time. All right, let's look at one more slightly more challenging problem. Again, we're going to determine the exact values for as many side lengths and angle measures that we can. We have a right triangle where one of the non-right angles is alpha equals pi over 7, and the leg adjacent this angle has length 5. Okay, so here is my standard right triangle. Always looks the same, never to scale. I'm going to throw you off a little bit. I'm going to call this upper angle pi over 7, and so the leg adjacent to that would have to be this leg, so this is 5. All right, so let's actually start this time by finding the missing angle. So I'll give you a minute to do that. Pause the video, find that missing angle like we did on the previous example. All right, so again, we know that this missing angle, let's call it beta, plus the given angle pi over 7 has to add up to be 90 degrees, or in radians has to equal pi over 2. So the angle beta will equal pi over 2 minus pi over 7. We'll get a common denominator, so 7 pi over 14 minus 2 pi over 14, and that angle beta would be 5 pi over 14. All right, so we now have all three angles in that triangle, and now we'll turn our attention to finding the missing sides. So we have this opposite side from the angle given, pi over 7, and then we also have the hypotenuse. And let's look at cosine first. We know that the cosine of pi over 7 would equal the adjacent side, so 5 is adjacent to the angle pi over 7, divided by the hypotenuse. And we're trying to solve for the hypotenuse, but it's in the denominator, so we're going to actually multiply both sides by the hypotenuse to get that out of the denominator. So we'll have the hypotenuse times the cosine of pi over 7 equals 5. And since we're trying to get the hypotenuse alone, we will divide both sides by the cosine of pi over 7. So we now know that the hypotenuse is equal to 5 divided by the cosine of pi over 7. I think I can fit that in our picture, so I will make an attempt to do that. 5 divided by the cosine of pi over 7. And so the last thing we need to do is identify the length of the opposite side. Well, we know that the sine function, we'll pick a different color here. We know that the sine of pi over 7 equals the opposite side divided by the hypotenuse. And we know the hypotenuse is 5 over the cosine of pi over 7. So notice right now we are dividing by the hypotenuse. If we want to get the hypotenuse alone, instead of dividing, if we want to get the opposite side alone, instead of dividing by the hypotenuse, we're going to multiply both sides of the hypotenuse. So we actually are going to end up with 5 over the cosine of pi over 7 times the sine of pi over 7, and that will give us the opposite side. So I'm going to rearrange this just a little bit. Since we're multiplying fractions, we could think about this as 5 times the sine of pi over 7 divided by the cosine of pi over 7, and that would give us the opposite side. So one thing I want you to notice by this rearrangement is that the opposite side turns out to involve a ratio of the sine and the cosine function at pi over 7. And we're going to see that show up later in our studies. So just wanted to point that out to you. Hope these video examples helped you as you work on some similar problems. Thanks for watching.